Now, we put it to use. We have one server and one client. Everything the protocol can do: tools, resources, ROMs, structured return types, error handling, images, progress, and notifications. We are going to run it with two different transports. The server logic is identical. The only thing that changes is how the client connects and how the server starts. MCP defines three transports, namely stdio, which is a local subprocess. Client spawns the server, communicates over std-in, std-out. SSE, HTTP with server sent events. Persistent connection, server pushes events. Streamable HTTP, HTTP with optional streaming. The current recommended production transport. We show stdio and streamable HTTP. We skip SSE, and that's intentional. SSE transport is being superseded by streamable HTTP. SSE was the original HTTP transport in MCP. Streamable HTTP replaces it. It supports stateful and stateless modes, resumability, JSON, or SSE response formats, and scales better across multiple nodes. The SDK still ships SSE for backwards compatibility, but all the new docs point you to streamable HTTP for anything network facing. There's also a V2 of the SDK in development right now. The release notes say that the next spec revision will heavily change how the transport layer works. SSE is not the direction the protocol is going. Teaching SSE here would mean teaching something you'd immediately unlearn, so we skip it. stdio is the local process communication. The client launches the server as a subprocess and pipes messages over std-in, std-out. Zero network, zero port conflicts. It spawns them and owns them. stdio server parameters is just a config object. What binary to run, what arguments to pass. stdio_client launches it as a subprocess and returns two streams. Client session wraps those streams. After initialize, everything else is identical. No host, no port. Streamable HTTP is for network accessible servers. The server runs as a persistent process. Clients connect over HTTP. This is the recommended transport for anything deployed. APIs, cloud services, multi-client setups. JSON_response equal to true tells fast MCP to respond with plain JSON rather than SSE streamed responses. The SDK docs recommend this with stateless_HTTP equal to true for production scalability. We keep it simple here, but the flag is the same. Default mount path is /MCP. Default port is 8000. Run the server before the client. Instead of a subprocess config, you pass a URL. So after initialize, the API is identical. Same session.call_to, same session.list_tools, same everything. The client body is 6 sections. They are the same in both transport versions. This is the point. Transport is set up. Once you have a session, you forget about it. We go simplest to most complex. One thing to anchor in: client session doesn't know or care which transport connected it. Once you have read and write streams and session.initialize complete, you write the same code regardless. Transport is a setup concern, not an API concern. That's MCP by design. All examples and patterns demonstrated in this tutorial are inspired by the official examples provided in the examples directory of the Model Context Protocol Python SDK. This tutorial builds on those foundational patterns to help you understand and apply them in a practical, hands-on way. If you find this helpful, please consider supporting my channel. I'll continue doing my best to cover and explain as many patterns as possible in a clear and structured way. Thank you.